Hi, this is Wes Simpson with another edition of Summer Sessions on Media over IP, brought to you by AIMS and the VSF. With me today is Jed Deame, CEO from Nextera Video, which is headquartered in Sacramento, California. Jed is going to be talking to us about what is NMOS, and he's also going to give us a secure control case study. Welcome, Jed.
Hey, thanks, Wes. Great to be here.
Hey, so glad to have you. Hey, Jed, I don't know a lot about Nextera Video. Could you share what you folks do with our audience here?
Yeah, absolutely. We're providers of IP cores for video over IP, things like 2110, 2059, 2022, and of course, NMOS.
Wow, that sounds like a lot of work.
Yeah, it keeps us busy, but we're here to help manufacturers provide solutions for their customers and to really ease that process. So we're happy to do whatever we can to help 2110 and NMOS really take off.
Well, good. I bet you have to spend a lot of time keeping up with the new standards, huh?
Yeah, absolutely. It's a busy week of weekly calls, 2110 calls, and AMWA calls, and all that. But it's worth it because it's really good stuff.
Great. Well, let's get started. So, what is NMOS?
So today we're going to talk about NMOS, what it is. We're going to describe the key components in some very simple terms. Then we're going to talk about securing NMOS, which is some of the latest work that's being done. And then finally, we'll go into a case study and we'll talk about how secure control can be accomplished with NMOS. So what is NMOS? Well, it stands for Networked Media Open Specification. It was developed by AMWA, which is the Advanced Media Workflow Association. And it's delivered in the form of an open spec published on the AMWA website. What it does is it enables 2110 equipment manufacturers to provide solutions to seamlessly interoperate. So it's standards-based interoperability for 2110 networks, and it's actually also being extended to other types of networks. The end goal is really to bring plug and play to video over IP. So you can see on the right, there's traditional button panels like SDI button panels. With a software upgrade, those can be turned into NMOS button panels. So you can get the same functionality you had in SDI and the same push button simplicity using NMOS. So how does NMOS work? Well, it's got a few different parts of the spec, which I'll talk through later, but the basic functionality is shown in this drawing here. On the far left, you see there's some sources. These could be cameras, for instance, that are 2110 enabled. And on the lower right, there's a display that's 2110 enabled. So when these devices first power up, they notify a device called a registry, which is a new device that wasn't in SDI systems, but is what gives us this plug and play capability. Just like when you plug a printer into your PC, it shows up. It uses discovery technology to tell the PC that it's there. Same technology here. So the registry then knows what devices are plugged in. So the control panel can query that register and see, oh, okay, I've got two cameras and a monitor now in my system. Let's do a switch. Fine. So what it does is it sends a command to the monitor to tell it to subscribe to the multicast stream of one of those two sources. And it uses a technology called IGMP, Internet Group Management Protocol, to tell the switch. So essentially what it does is it subscribes to the multicast stream of the bottom camera in this example, and then it leaves the stream of the top camera. And that's how we do a connection in NMOS. So how is NMOS accessed? So this is from a control system perspective. It's accessed through a set of APIs. API is just an application program interface. It's a way to abstract the details of the hardware and the registers from the control system so that it's presented in a nice standard abstracted way. In this case, we use a RESTful API, which is just HTTP puts and gets, so very simple commands. And you can actually see what these look like. The commands that are sent across an NMOS system are very much like commands that you might type in a web browser, except you type in the IP address of the device that you want, and this x-NMOS tells it to go to the NMOS resource, and then you can look at the nodes or the query resource, or you can do audio channel mappings, look at security, etc. So these are the commands that the control system would send to an NMOS device in order to access it. So what are the interfaces? So Here's a diagram that talks about how this abstraction works. So this big box on the bottom, think of it as the 2110 product. Could be a gateway or a server or something like that. He wants to be controlled by a push button, a button panel like this 2110 controller at the top. So that's done via HTTP, as I mentioned. So commands come into the standard interface. This blue box in the middle is the NMOS node API, and that provides a standard mapping of commands to the control system. So he can send in the controls, the NMOS logic on the board, then talks to the internal registers, the 2110 hardware, to tell it to subscribe to a stream coming from this upper left, this content traffic. So 2110 camera could come in, for instance, or an output could go to a monitor. And it's all under the control of PTP for precision timing. So let's dig into a little bit more details on some of the components of NMOS. The first is ISO4. Again, this is the part that does this plug and play registration discovery. It's got three different APIs. The first is the node API. This is the little piece of software that runs in all the nodes, the 2110 gateways, cameras, monitors, etc. And then there's two more APIs called a registration API and a query API. These live in this registry, which contains the map of the entire system. Now that we've got our map, how do we do a switch? Well, that's the next piece. That's ISO 5. This is connection management. So what the connection management does is essentially connect senders to receivers. So as you can see in the pictures on the bottom, the sender is connected through what's called an activation. And there's three ways we can do activations. We can do an immediate activation, which is do it now, cut the switch immediately. We can do relative, which is switch in 5 seconds. Or we could do an absolute, so switch at 12 noon, for instance. Next part of NMOS is audio handling. So one of the nice things we had in SDI is we were able to do audio shuffling in our SDI router. So you could de-embed, shuffle, mix, and re-embed. Well, it turns out in 2110, with the help of NMOS, we're able to actually do this automatically without any additional hardware. This is because audio streams are sent independently of the video streams. So with this audio mapping API, it allows us to do things like map our inputs and outputs and define the connectivity between them. These are all done through a graphical type representation that I'll show you in the next slides. So the best way to demonstrate this is to look at the demo that we did at NAB last year in the IP showcase. We actually had a multi-vendor interoperability demo showing this ISO 8 audio mapping. You can see the equipment on the right, and we had 3 16-channel senders and 2 16-channel receivers that were able to connect together in any order that we wanted. Here's what the GUI looks like. This is just one example, but on the far left is the inputs, so 16 audio channels coming in to a particular node. And then on the top are the outputs, 16 outputs in this case. So just by clicking these little boxes, we're able to map any input to any output. So in this case, what we're doing is we're doing like a channel inversion. So we're mapping input 16 to output 1 and input 1 to input 16. So as you can see here, we're taking the signal on the upper left and outputting it on the lower right. You can see the audio levels are inverted because the channel 1, which was the highest volume, is now channel 16 on the output. So the newest part of NMOS is called ISO 9. This is a system resource. It provides a way for NMOS and 2110 devices to understand the environment they're in. And it's located using a process called DNS service discovery. So it's an automatic way for all the devices to actually find this information. The types of information that are included are things like the system ID that's randomly generated each facility. So devices know if they've been moved from one facility to another. They know whether to do like a cold restart or whether to come up the same way they went down. The protocol is described, is it secure or not? What NMOS API version is being used, what PTP domains used so they can all run on the same clock, heartbeat intervals for the registration and discovery service, and also any kind of syslog servers that might be out there. So the next big part of NMOS is the security aspect. So we've talked about how we can discover devices and switch them and manage our audio and control them from a system level. how do we now add a layer of security, which has really been sorely needed in control for broadcast for a long time? Well, there's a few new parts of NMOS. Specifically, there's a best common practice BCP called BCP 003, 01, and 02, and there's a new IS called IS10. These are for the control layer that allow to have interoperability between the encryption for the control on the device networks. The second aspect of security is ESIPs. This is not yet standardized, but there are some ad hoc schemes in place, which I'll describe a little bit later. And these work well in single vendor environments. So the goals of the NMOS security are fourfold. First is confidentiality. We need to make sure that any data that we're moving back and forth is unreadable to any third parties. The second is identification. How do we know that the API we're interacting with is owned by a trusted party? So we know we've got devices that we can trust. Integrity, making sure there's nothing that's been tampered with in these communications. And authentication, confirming that the user that's trying to make this request or this control command is actually authorized to do so. So for control security, there's two components of it. First is transport layer security, TLS. This is covered by the best current practice. What this essentially is using HTTPS instead of HTTP to encrypt all the TCP communications between the NMOS devices. The second piece of this is the Authorization Server, which is covered by BCP 00302 as well as IS10. This allows us to manage which users are allowed on the system and what access control capabilities they have. We should probably talk a little bit about how the encryption is done before we go too much further. There's a technology called PKI, which is very commonly used, and this is public key encryption, public key infrastructure. It manages keys and allows the HTTPS to actually work on IP networks. A simple example is shown on the right. If you've got a public key that's known by anyone, this can actually be used to encrypt data and send across the network. But only the person with the matching private key can decrypt it. So this is how HTTPS works in a very simple form. Of course, there's much more complex ways to do it, and NMOS supports all these different cipher suites. I'm not going to go into these in this presentation. If you're interested in these, you can watch my presentation from last year's IP Showcase for lots of detail on this. So let's go through a secure communications example. There's a little animation that I'm going to walk you through here. So first we start with three components. We've got an IP source, we've got an IP destination, and a broadcast controller. And so now we want to do a switch. So how do we do it? Well, there's a new device that's now part of the system. This is the Authentication Server. This is the piece that authorizes the user to do this particular switch. So first we initiate a switch. It sends an authorization request using OAuth to the server. The server then responds with a token, assuming that you're an authorized user. This is called a JWT, a JSON Web Token. This token is then used by the broadcast controller to send its activation request to the IP source. He now compares it with a public key that comes from the authentication server, so he knows that that's a valid key and a valid request. So he starts sending his essence flow. But that's not the whole story. We need to actually tell the destination to subscribe to this stream. So we send that same activation request with that JWT token. The IP destination now compares that with that same public key from the server. And guess what? The flow is now able to go from the source to the destination. So there are 6 core technologies that are used for the security functions of NMOS. The first is PKI, which we talked about, HTTPS, REST, remember, which is the HTTPS puts and gets for the communication, JSON, JavaScript object notation, which is used for the key value pairs, OAuth, which is this authentication, and the JWT tokens. So now I'd like to talk a little bit about a secure case study for a customer that we worked with that was doing control rooms for both Pro AV and also military customers. And they had some really interesting requirements that their systems needed to be cost effective as well as being highly secure. So the requirements are shown here on the left. The first is they wanted encrypted control. So fortunately, we've got NMOS BCP003 to do that. This is our HTTPS. So we employed that to cover the control aspects. Well, then they also wanted the authorization server. Again, this is covered by NMOS IS10. This is what allows users to be logged in the system and capabilities of the users to be specified. For efficiency, they wanted to be able to move 4K P60 over gigabit Ethernet. For this, we adopted JPEG XS, which is the newest, most efficient codec that can do 10, 12 to 1, even 14 to 1 visually lossless compression. So very cost-effective solution for IP networks. Now, beyond that, they wanted some unique things that weren't quite ready by the standards organizations. But fortunately, NMOS is extensible, so we're able to extend it to meet some of these applications. The first was encrypted essence. So I actually wanted to encrypt the video and the audio and the metadata moving from point A to point B. So we use some of the ciphers that we mentioned previously to actually secure all of this data just by extending NMOS and using PKI encryption. Second thing they wanted is a unified routing and moding interface. NMOS as it stands today is currently designed just to do control, switching. But devices also have modes that need to be set. You might want to set a bit rate, for instance, for the codec, or you might want to set some other parameters. Again, we were able to extend NMOS through some proprietary extensions for this device moding. Finally, they wanted to do a KVM type extension. That's keyboard, video, mouse. So USB, human interface devices, bidirectional control. And NMOS lent itself quite well to extensions for USB as well. So here's a diagram of what the system looked like in the end. In the upper left, we have some SDI sources, cameras in this case. In the upper right, we've got a bunch of servers, workstations that have HDMI displays on them. And at the bottom, we had users that needed to access those HDMI outputs. So rather than actually sitting in front of the displays in the workstation in the control room, they wanted the users on the bottom with keyboard, mouse, display, and then just rack-mounted servers in the back to actually be running most of the main functions of the control rooms. So the way this worked is we're able to move the data securely encrypted from the servers to the control stations in the bottom. This was all under a system management and secure control facility using the NMOS capabilities we looked at. And then in the top center, we're also able to have a remote station that could take any one of these devices and display and even control it through the keyboard and mouse interface. So what's the future of NMOS? Well, NMOS has got a strong foothold in broadcast. It's a very good solution to provide interoperable standards-based control. In Pro AV, some additional features are needed. So the AMWA group has gotten together and created this thing called IPMX, the IP media experience that extends NMOS into the Pro AV space. So it's new standards for things like USB, HDMI, HDCP, etc. If you want full details on this, stay tuned for the webinar next week, right here. So why NMOS rocks? It really does. ISO 4 and ISO 5 are stable, solid, mature, and used widely. There are new facilities like ISO 8 to do the audio mapping and ISO 9 for system discovery that really take NMOS to a new level, really surpassing some of the capability that was provided in the SDI space. Some of the new features on the security side are crucial. They're sorely needed in control systems for some time, and NMOS now brings those to the 2110 video over IP system. And finally, NMOS is the glue that really holds together all these 2110 systems and enables new business value to be extracted. And it can be extended, as has been shown in the case study, to adapt to specific functionality required for specific applications. Well, that's what I think. Well, what do customers think? Well, if you look at the EBU, back in 2018, they published a document called Minimum User Requirements to Build and Manage an IP-Based Facility. And guess what? They called out NMOS, ISO 4, ISO 5, ISO 8. They felt so strongly about this that they actually developed a testing program called the JTNM Tested Program. You can learn all about that at jtnm.org. You can see these badges that indicate products or IP cores actually live up to the specifications and the testing that's been done for this program. So thank you very much. That's all I have for today. If you need any help with developing 2110 or NMOS systems, my contact information is provided below. Thanks, Wes.
Thanks, Jed. I'm glad that everything worked out. I wanted to dig a little bit deeper here. So what kind of work is going on inside AMWA right now? What new things are being developed in NMOS?
Yeah, so that's a good question. So there's a lot of work on the security side. There's more to do. We just finished a interop where we tested some of the latest features of the best current practices in the IS-10 that we talked about. So I think that's really progressing quite well. There's some new things that are being worked on, such as control interfaces for event and tally. So definitely a flurry of activity.
So when will manufacturers be able to use some of these new standards for security and things like that?
So there's still a bit more work to be done, but fortunately, AMWA is a very agile organization. We should have these specs in place within the next few months, and so that core developers like ourselves can get them out there and manufacturers can design products around them. So it's a very agile process. It's much faster than you might see in a SMPTE spec because we know that there's a very strong demand for these. We want to make sure that we're able to get them out quite quickly.
Yeah, security is really a super important thing for people to be able to properly work with, and make sure that all of our networks are going to be safe from not only external threats, but also that people that are working on them and devices that are operating on them stay within their required domains. They don't go adventuring out to places where they shouldn't be.
Right, that's the key. Anytime you bring IP into the equation, security becomes a concern. So we've heard from lots of different customers around the world that security is a key feature for them, and it's nice that we've got these capabilities, and the system really lends itself to adding these secure protections that are required.
Okay, well, thanks so much for your time today, and we appreciate it and look forward to doing some more webinars with you in the future. Thanks a lot, Jed.
Thanks, Wes. Take care.
All right, you too. I see it looks like it's pretty nice weather in your part of the world there right now.
Yeah, it's been over 100 degrees the last few days, so
wow.
It's clear. I'm not sure I would call it nice. It's a little tough to spend time outside, but it's going to cool off this weekend, so that'll be good.
Yeah. It's we haven't gotten any 100-degree weather here all year, and I hope we don't run into that. 90s are bad enough in my part of the world.